Hi everyone, and welcome to this very exciting series where we will be examining and discussing capsule networks. And I say exciting because capsule networks are something that's relatively new and promising within the industry. So quickly, as an introduction, the capsule network is the suggestion that artificial neural networks should use local capsules that perform some quite complicated internal computations on their inputs, and then encapsulate the result of these computations into a small vector of highly informative outputs. And that's really, a quick broken down introduction that we're going to dive into further. So try and keep that in mind and start thinking about a capsule compared to using neurons in an artificial neural network. But before we dive further in and start examining the useful information related to capsule networks, I think it would be a great idea to look at the origin of the capsule network. Capsule networks were introduced by Geoffrey Hinton and his team when they published 2 papers promising a completely new type of neural network. They are also published an algorithm called dynamic routing between capsules, allowing the training of such a network. Now, if the name Geoffrey Hinton isn't familiar, that's okay, but I advise taking a look at some of his contributions since he is seen as one of the founders of deep learning and has invented a range of algorithms. If you want to read the published paper, you can find it here, and I would recommend reading through it if you get the chance. Now, for those of you who haven't heard of capsule networks to this point, that's also fine because we see a lot of information and attention provided to convolutional neural networks, but CapsNet actually reached better performance on the MINCE dataset. And I would imagine if you aren't brand new that you've come across the MINCE dataset. If you are very new to this, the MINCE dataset is a dataset of handwritten digits. It's just very prominent within deep learning, AI, ML, data science, and is a great dataset to use. And a lot of benchmarks come through it and test on it within the industry. Great. So now we've covered a brief historical look and a possible better performing algorithm. So we need to keep an eye on it since it will surely lead to new research in algorithms. But in order to better understand the capsule network and its benefits, we actually have to first look at convolutional neural networks. And there is no doubt convolutional neural networks are awesome, and they are one of the reasons deep learning is so popular today. They can do some amazing things, but they do have their limits and drawbacks. So the main component of a CNN is a convolutional layer, and its job is to detect important features in the image pixels. Layers that are deeper will learn to detect simple features such as edges and color gradients, and higher layers combine simple features into more complex features. The way CNNs use max pooling or successive convolutional layers is actually seen as a big drawback, although the performance is strong, because max pooling is losing valuable information. And in a Reddit AMA, Hinton even stated that it's a disaster when saying that the pooling operation used in a convolutional neural network is a big mistake, and the fact that it works so well is a disaster. If you want to see the AMA, the reference to the AMA on Reddit, you can follow the link here. In addition, although CNNs are a crucial part of deep learning, Aurélien Guérin from O'Reilly did a great job summing up some of the other issues with convolutional neural networks and touched on the pooling layer again. Now, some of these include the fact that CNNs need a large amount of data. CapsNet uses much less training data. CNNs don't handle ambiguity well, and CapsNets do. They can perform well even on crowded scenes. And here's that reference to the pooling layer again, where CNNs lose plenty of information in the pooling layers. All right, so we can see some drawbacks with convolutional neural networks, and nice job working through that as it's necessary to make these comparisons. I mean, CNNs, neural networks, these are the state of the art, very prominent within deep learning. But this algorithm here, the CapsNet, is emerging, and it's starting to show you that it has some promising features. Now, we could take a quick break, and in the next video, we're going to examine what exactly are capsule networks and go over some of the value information related to them. If you have any questions, please share them below. As always, subscribe to the Super Data Science channel as it's a great way to keep up to date with new information in the industry, such as capsule networks. You can even check out the podcast, and I will see you in the next video.